So good morning. Thank you for the warm welcome, and thank you to AED for such an incredible setup. I feel quite like Madonna with my headset, and and I don't remember the last time I was standing in such a big in front of such a big screen for the PowerPoint. So I think you'll all be able to see every word in perfect clarity, right? I don't know if we're going to hit quite 90 minutes, right? Normally this presentation is about 45, so to help with the schedule, but also to make sure that I take the time to answer every question that you've come this morning, right, to have answered about SDVoE. Feel free to raise a hand or let me know if you want to stop at any point during the presentation and deal with a question or dive into any of the topics that are covered there. Because in terms of material, there's only about 20 slides, right? So it's not so long. So from high level, the intention with my presentation is to give you an overview of what the Alliance is all about, to give you some taste of the technologies that underlie SDVoE systems, and then most important for me is to answer the question of how to participate, right? Because SDVoE is ultimately designed to engage the broader Pro AV industry. If we don't do this, we're not achieving our mission, all right? So we'll start with an open question, convergence, where are we, right? Convergence has been a concept and an idea, a vision for the future in Pro AV that's been talked about and waving hands for more than a decade, right? You've heard this term, convergence. There's something about Pro AV applications that have sort of stopped this move to full adoption of Ethernet as the medium for transmission of signal, and there are some very good reasons why. It's simple, in fact. It's that until very recently, the network infrastructure was simply not suitable for a certain category of application, right, in Pro AV, and this is why matrix switching has prevailed and persisted for so long, right? Everybody in this room is quite familiar with the feeling when you look at a project of when to go AV over IP or when to go matrix switch, right? And this is a story of performance, and this is what SDVoE has the technology and through the partnerships, the infrastructure to deliver on, right? So I'm going to dig into this in the presentation. Meantime, over this period of 10 plus years that everybody was worrying about how to adapt to the new converged world, audio, right? Control has moved to the cloud for some time now. Audio has been moving to IP for some time now, right? It's become quite standard in terms of implementation. The last to fall will be matrix switch. So this brings us to two of the key themes for the presentation this morning, and the first one is interoperability, which is a very important building block within the SDVoE concept. And the second is raw performance, right? Because it's this performance capability that makes the first difference. So formal statement of mission for the Alliance, right? Software-defined video over Ethernet. Some key points. Number one, while the Alliance is funded by contribution from the membership, so every company logo that you see on the SDVoE stand at a show like ISE or Infocom, these are companies that are making a material contribution to be part of this Alliance, right? Something very real for them. But the Alliance itself is independent and not for profit, right? So it's a standard business structure. There's a board of directors, and the Alliance really is acting on behalf of that membership, right? So this is an important concept, right? Second, and I'm going to show you recap some of the key, membership groups, but I want to point out that it brings together a really diverse group of companies, right? It's not just a bunch of end box manufacturers, right? It's not just infrastructure providers, but it's in fact endpoint, infrastructure, cabling ecosystem, as well even as software providers, right? And this speaks to the strength of the Alliance vision, right? And we believe the long-term viability of the SDVoE concept in the market, right? Because it brings together so many stakeholders. The ultimate goal, of course, for SDVoE is to create a platform, right? This is a very common concept. This is the vision for convergence, right? Convergence isn't just about using Ethernet as a better way to do signal distribution, but it's in fact using the flexibility and scalability and performance of Ethernet to create a platform, right? In the same way that the smartphone in your pocket is in fact, in the applications you use, is in fact the result of a platform that has been built and not just infrastructure plus device. So SDVoE was launched 2017 with 6 founding member companies. Laurent is in the back of the room, my alliance colleague, right? Good morning, Laurent. So Laurent was one of the founders, right? And in fact, serves on the board of directors for SDVoE. He's been very early participant in articulating this vision and bringing it to reality, right? In the short time that the Alliance has been active, we have grown to just over 45 members, right, and starting to really accelerate. Infocom in Orlando, if any of you were there, this was another milestone show for the Alliance. Bigger booth, more companies, more products, and again, more diversity, right? And this goes back right even to the founding member group, right? If you look at the companies that are there at the time, right, in 2017, there was in fact only one endpoint manufacturer active in the Alliance at founding, right? That was ZV, that was making transmitters and receivers. Christie and Sony at the time, both display manufacturers, right? And people who had, in fact, those guys had come into the Alliance ecosystem primarily because they were looking for a better way to get signals to their big, beautiful screens, right? And Semtech and Aquantia, both chipset suppliers, right? Supporting the vision of these endpoint manufacturers. So the Alliance members, you know, we have a common vision that eventually all communication moves to Ethernet, right? This has been true in almost every industry and almost sort of every mode of communication that we all deal with day to day, right? I'm a Canadian guy, so I lived through the transition away from a fixed PBX, right? When everything went soft and our big beloved Nortel disappeared, right? This was very dramatic. This is, you know, this is something that happened in 2-3 years, right? Once Ethernet starts to touch an industry, it's transformed, right? And Pro AV matrix switching is one of the last to hold on, driven largely by performance, but this is, you know, SDVoE is here to change this. So the vision of the members is that this move to Ethernet as a means for signal distribution is a good thing for the Pro AV industry finally, right? It's not a bad thing, it's something to be embraced, yeah? And so the Alliance members, we want to push this transition, right? We want to give shape to the transition. And we want to do this by establishing standards, by templating best practice, right? By sharing knowledge amongst each other. And of course, by reaching out to end users to help them understand the power and the capability of these new systems that their partners in manufacturing and system integration are designing. So in the years since Alliance founding, there really isn't a geography, you know, with some small exceptions that hasn't got SDVoE system installations, right? Our manufacturers are active in, you know, in every territory in the world. And likewise, there isn't really an application space within the classic verticals of professional AV that hasn't been touched by an SDVoE system, right? You have a bunch of very public references on this slide. Some of the snapshots, these are all case studies that you can see on the SDVoE website. And what they have in common is in each case there was a requirement for absolutely pristine 4K signal distribution, right? And real time, right? There was something about the application that meant that there needed to be, you know, no perceptible delay between the source and the screen, whether it's because it's a bunch of people in the same sporting stadium or, you know, you see top left image is the Zurich Opera House where performers are singing on stage and it's being shown on multiple big screens at the same time. Obviously, there can't be a delay between those two experiences. And SDVoE is the only platform that's able to deliver on this. One of the use cases that's a personal favorite is one that you'll hear from Jay later this afternoon. This is Yale University, and a classic case of an installation which is built around performance, right? So this is kind of a lecture overflow, you know, application where they're connecting different rooms on a in North America, a very historic campus, right? So it's, for us, a very old building, something that you don't want to touch the infrastructure or renovate or suddenly expand, right? So they have a real practical problem when they want to connect rooms together. But very interestingly, the IDK implementation uses that 10 gigabit Ethernet link to pass not just the high-powered or high-resolution AV signal, but also control and even USB camera feed for monitoring, right? You'll hear some details of this. It's convergence in action, right? This is the realization of the dream, right? just like the membership and the number of project references, the ecosystem starts to get really diverse, and we're very happy to see that manufacturers are getting very creative, right? One of the things that we used to say back in 2017, if you came to meet me at a trade show on the Alliance stand, I would say, I can't wait for somebody to show up here with something that we didn't think of, right? Well, it's already starting to happen, right? So at Infocom this year, there were companies showing, 60601 compliance. That's medical grade transmitters and receivers. There were ruggedized products, multiple wall plate designs. If any of you here follow Christie, right? Their new microtiles product is fully driven by SDVoE, right? And is part of a vision that is quite public and quite obvious that they intend to have native SDVoE inputs on all of their display products, right? Regardless of what it is, projector, fixed screen, microtile, etc. Yeah. We had customers or participants in the Alliance showing up with different iterations of control software applications. There's a development that was done with one of the manufacturers and Netgear to collaborate on an input module, right? So this is for a particular model of switch that Laurent is going to present to you later today, that brings density and supports local inputs to a switch, right? So this looks a lot more like a matrix switch than anything before, right? But in reality, you're just leveraging the flexibility of Ethernet and the power of this SDVoE architecture. Yeah. Another one that you're going to hear about today from Jay is the SDVoE Dante audio bridge, right? Dante, incidentally, is a very good model for what SDVoE is trying to achieve and how it's trying to behave in the market, right? Audinate had a concept, had a technology, and built an alliance to help the market understand and implement this, this vision and benefit from it, right? And SDVoE shares a lot of similarity with this approach. Another one that came at the show that I really liked is a hybrid, or what we're calling a hybrid, which is SDVoE, and actually there's a mistake on the slide. It's H.265, right? So it's a single HDMI input, and then it's putting two flavors out onto the network. And of course, this is actually just an integration story, right? Somebody has put both chipsets into the same device, right? But it speaks to the creativity that once you match your AV source, right, to an encoder that's capable of delivering in the real-time environment, so to the, to the giant screen, as well as to the record server or to the transcoder to go out over LAN or WAN or campus area network, you can start to design applications that are really incredibly flexible, right, and have kind of no limit. Yeah. So far, so good? No questions? Yeah. So how does this vision translate into actual activity? I'm going to say it a couple of times today because I really want to make sure you guys, take it home with you. It's that SDVoE is primarily about education, right? It's about organizing for seminars such as this one, webinars. There's a huge body of information on the SDVoE website, and in fact, there's something called SDVoE Academy, right? That's really important in our world and offers the opportunity not only to access sort of on-demand, call them training or informational modules, right? So there's an education department that's endlessly, creating content, particularly video content, so you can learn about little bits and pieces of the technology. But there's also a mode, sort of a self-certification mode, right? So as a registered user of Academy, you can log on, follow some of the material, and then get, there's a certification exam, right? So you can publish your expertise, right? And what this means is that if you're a system designer or system integrator and you have a customer that's interested in SDVoE, as a certified SDVoE design partner, you can point to this accreditation, right, and give them confidence that you understand this technology and can help them work out if it's the right basis for their system, right? So a little bit about one of the key building blocks for SDVoE. This is, of course, IEEE standards-based 10 gigabit Ethernet, right? And the concept is very similar. And Laurent will go into, I think, a little bit more detail, right? But the idea is that, You know, there's a much bigger industry, a much bigger community of people spending time and energy on R&D doing Ethernet, right, than all of Pro AV taken together, right? There is no battling the Ethernet machine, right? The Ethernet machine is enormous, well established. It's one of the oldest pieces of technology that we all interact with every day, right? And there's no sign that it's ever going to disappear, right? All that changes is the speeds go up and the costs go down, right? But otherwise, this is a foundation for signal distribution that's very solid, right? So the SDVoE architecture, right, leverages this power, right? And we concern ourselves with only the upper layers of the OSI model, right? So we're worried about layers 5 through 7, right? So 5 where you have session management, right? And devices, you have the technology to allow devices on an SDVoE system or network to detect each other and start communicating, right? But then on top of that, you have what's known as the SDVoE API, right? And this is one of the keys to the interoperability story, right? Which is really not very complicated. It starts with standards-based Ethernet. It builds on a common engine, right? So all of the endpoints use a chipset with a similar technology, and then add to this a common API, right? And this is how interoperability can be guaranteed across devices from a single manufacturer, but also across the larger ecosystem, right? So I'll give you a couple of examples of how this works, what it means. SDVoE systems by themselves have 3 kind of core modes of operation, right? The first one is known mostly as Genlock mode, right? This is very simple to understand. The idea is that what comes in is what goes out, right? And Genlock mode is the mode of operation that's used for the most time-sensitive applications, right? That's when you want to have performance that's completely analogous to making a direct HDMI connection between source and display, right? So absolute lowest latency, no manipulation of the pixels in the pipeline, right? This is the absolute fastest mode for signal distribution. The second is what we call quick scaling, right? So the SDVoE chipset engine has an ability to do scaling inline, right? So it's like a pixel pipeline scaling. This gives us the ability to claim the industry's lowest latency scaling capability because there's no frame buffer being implemented to manage this scaling. It allows you to do it on the fly and gives the flexibility at the application level to use, you know, raw power that, you know, the IP-NINJAR, as an example, has in transmit and receive side to do scaling on both ends, right, without a huge latency penalty. And this gives a lot of flexibility to build creative applications, right, up to and including very advanced and complex multi-view applications, right, with simple single transmit-receive pairs, right. The last is what we call a full processing mode, right? Full processing is when we use the capability that I described in transmitters and receivers to do scaling at either or both ends, right? As well as to do some buffering to offer instant source switching, right? So you can even see some examples online of typical signal distribution demonstrations that are done by Alliance member companies. There was a great one I'm going to describe in a couple slides actually from Infocom that showed the performance of this system. In all cases, even with all of the processing enabled and maximum manipulation, the systems are never more than 2 frames of delay, right? So you're in almost all cases well below the threshold for human perception, right? And again, like the flat architecture that's made possible by Ethernet, this gives you flexibility when you're designing your system, right? Because you don't have to be concerned. You know that you're going to fit overall within the budget of the application requirements. So a little bit more about this SDVoE API, right? So this is the standard interface that controls switching, endpoint configuration, and processing mode for the endpoints. This is an abstraction layer, right, between the core chipset and the application that an individual SDVoE manufacturer has created to manage their systems, right? The API is sort of all of the possible things that an SDVoE endpoint can do. it gets then shaped, right, or filtered by this manufacturer application that decides what features to expose and how to expose them, right? And this is an important concept, right, because you know, it's a bit odd that in every SDVoE presentation, a lot of the discussion is about the capabilities of the transmitters and receivers, right? The endpoints, right? Or even the architecture of the network itself, right? But the real story in this is actually software, right? It's the SDVoE, right? The concept is that here we're building a platform and we're opening a room for communication because the thing that matters to end users is their workflow, right? They actually really don't care how you got the signal from A to B. What they care about is it going to be effective for whatever it is that I want to do, for the collaboration that I want to have, for the presentation I want to make, for the entertainment experience that we're building in the stadium, right? How is it for the end user, right? And this workflow is defined in software, right? So the intent here, what manufacturers like IDK are working to bring into the market is something that creates this platform and gives the maximum flexibility, right? So this API sits in between, right, device and the management layer, right, that's provided by the system manufacturer. You add to this Ethernet, which really brings three benefits, right? The first one is Ethernet is absolutely the lowest cost to move electrical bits from A to B, right? If any of you have been in the matrix switch building business, you can know that it's an incredibly expensive product to design, to build, to stock, to support, right? This is a tough way to move signals around because it's very resource intensive. Ethernet is very, very, very efficient, right? And it's an efficiency that's, you know, it's like a giant machine. You have this thing called Moore's Law, right, that we all benefit from, where the cost of technology goes down all the time, the cost of storage, the cost of networking. Ethernet is in this domain very squarely, right? So this is the first advantage that it brings to these systems. The second is flexibility, right? Compared to a matrix switch, an Ethernet-based signal distribution system does not need to be symmetrical, right? Customers can add and subtract and move, and you know, there's really anywhere the network goes, the signal goes, right? So this is a tremendous advantage for system design and long-term operation. And the last, of course, is scalability, right? The network can grow and grow and grow, right? Talk to your average customer about how they feel about their matrix a few years down the road, and almost always the same problem comes. They didn't like it because either they got stuck with a particular resolution, or they didn't like it because when they tried to add some more sources or add some more screens, that they had to completely forklift upgrade their system, right? This is not a characteristic of Ethernet. So a key message from the Alliance, a simple one, is that only 10G offers this flexibility, scalability, cost efficiency, right? The 10 gigabit Ethernet is the key to finally moving away from matrix switch as the core for time-sensitive signal distribution and into performance AV over IP, right? It's in addition the only way to realize convergence, right? I highlighted the convergence aspects of the Yale project, right? Which is really something worth digging into because this is not possible on a 1 gigabit Ethernet installation, right? 1 gig AV over IP is for sure a huge buzzword in the pro AV industry, right? Virtually every manufacturer has a 1 gig technology and market offering, right? The reality is that these are never, ever, ever going onto existing infrastructure, right? And one of the key or one of the simple messages or questions that the Alliance would pose is if you're always talking about new infrastructure, why wouldn't you go 10 gig, right? What IT manager is ever going to say, no, thank you, I have enough bandwidth, right? That's good for me. I don't need any more storage, right? No one says this, right? So to illustrate this, there's a couple of demonstration setups that the Alliance is famous for. The first one, if you visited an SDVoE Alliance stand since we were founded in 2017, you've probably seen the codec shootout, right? So this is a setup where we put identical screens together and push one source through multiple different AV over IP technologies, right? To help people understand and see for themselves real time what's the difference between an SDVoE system and motion JPEG codec or H.264 or some other kind of wavelet-based compression, right? What is the latency trade-off that you're making? What types of content are going to break those other codecs, and obviously how SDVoE is the only way to address the widest possible range of use cases and content and requirement. This year for Infocom, it's confusing for me with the two screens. I don't know which way to turn. For Infocom, we set up something that actually worked out really well as an illustration, right? So we're doing a couple of things here. It's, I think, fairly easy to describe. You have two setups, left and right. Left is SDVoE, right is classic matrix switch, right? We went on eBay and bought what we think is a good representation of a classic and performant matrix switch for the industry, right? Some of you will recognize what it is. For the SDVoE platform and for the matrix switch, both have access to the same range of sources. Both are feeding the same exact screens. Everything was done in 4K 30 because this is the max resolution capability of the matrix, right? Along the way, we also wanted to make a nice interoperability demonstration, right? So in fact, the SDVoE system was built out of products from 9 different manufacturers, right? And we had this demonstration all running on a single Crestron touch panel that had a couple of modes programmed into it, right? So you could go through the 3 core modes of performance for SDVoE, right? And what we would be looking at if we were standing live in front of this demo is I would first show you real-time signal distribution, right? So we would, on the touch panel, select sources and move them around. And the first thing that you would see is that the SDVoE is noticeably faster in switching than the matrix switch is, right? The second mode that we would open up would be what we call a display wall mode, where we're doing a little bit of processing on the endpoints. And the unique capabilities of SDVoE again stand out very quickly because number one, it would sync on that new configuration much more quickly than the matrix switch would. But secondly, and more important, is that the receivers can be put in full synchronization with a single source, right? And this avoids that kind of tearing or artifacts that you commonly see on a matrix switch, particularly when the content, I'll give an example from home. I'm Canadian. I love ice hockey. When you're living in Canada, it's on everywhere, on every screen when you go out in public. And if it's a video wall installation and they're using a matrix switch, an ice hockey rink has those vertical lines, and as the camera moves back and forth, you see, things are very quickly, you notice things are out of sync, right? This never happens with an SDVoE system, right? The third mode of demonstration that we set up for Infocom was a multi-view demo, right? So where we're taking multiple sources and doing picture-in-picture, picture-by-picture, sort of a mix of picture over picture. And of course, the matrix switch doesn't have any of these capabilities, right? In a system, you would have to plan for an external image processor, right, to handle this and create these experiences. But these are all built into a simple network or a simple setup of network switch, transmitter, receiver, right? It's not that much more complicated. So I'm excited about SDVoE, right? But in fact, there's not much that's new about it, right, in terms of concept, right? This idea of creating a platform is something that has been thought of before. We experience it in most of our daily lives, right? I don't think anybody in this room would think for a minute of leaving the house without your smartphone, right? And to give you an analogy, the engineer in Cupertino, when they were working on the first iPhone, they didn't imagine that Charles would use it to call some guy to come in his private car and pick him up at the airport and deliver him to a hotel where he orders a pizza brought by some other guy on a bike, right? They didn't imagine these applications. What they did imagine was creating a platform, right? And this is very much the same vision that SDVoE has in mind, right? And if I gave you earlier the example or the, I suggested that what we were excited about in the first couple of years was people showing up at the trade show with hardware implementations that we hadn't imagined, right? But the next phase will be software implementations that we haven't imagined, right? And this is what happens once you've created a platform, right? But meantime, the story is all about simplicity, right? This is a very basic architectural comparison between a system setup done using a matrix switch with one done using SDVoE endpoints. And I hope you noticed, Jay, I put IDK products all in here. Yes? So right away you can see how, there's some very easy cost arguments to make, right? That Infocom demonstration, the left side versus the right side, there was about a $7,000 difference, street price, right, between those two setups for much more capability on the SDVoE side, right? But in a beyond cost, you're talking about flexibility and simplicity, right? This is a much flatter architecture. There are fewer points of failure, right? There's fewer devices to understand, learn, and manage as a system operator. And if you're designing for a particular application, you know that you get more flexibility out of this one, right? You can drive more use cases. Your customer has more long-term capability than this solution, right? So what has already started to happen in just about every market that SDVoE is active is that you start to see tenders come out, you see end users approaching their favorite system designer or integration partner looking for SDVoE, right? They've heard about it, they'd like to know more, or they have a specific use case that they want to see implemented. And SDVoE is, within the world of Pro AV, we think uniquely well suited to engage this market and these users, right? And the idea is to collaborate with AV people and IT people and talk about things in a way that they're going to understand, right? Imagine, if I was a laptop sales guy from HP and I arrived in your office, which is all Dell, right? And I convince you that my HP laptop is fantastic, it's wonderful, it's going to be the best thing for your whole company, right? You say, yes, okay, we're going to start buying your Dell laptops. And then I say, oh, but by the way, you're going to have to upgrade your Exchange server because my laptop doesn't talk to that one, right? Or you have to change your browser because my browser isn't the same as the one from your Dell laptop. That would be crazy, right? You don't even think about this when you go shopping for a piece of IT hardware, right? And yet this is the core message from almost every Pro AV company, right? The Crestrons, the Extrons, the AMXs of the world, what they come to market to talk about is, if high performance is the requirement, then we have our wonderful matrix switch products, right? If you're looking for the flexibility of AV over IP, we have this also. But don't forget that an NVX only ever talks to an NVX forever and forever, right? This is, again, walled garden, closed off, single supply, right? This is, we think, quite out of tune with where the market is at and what people are looking for, right? SDVoE is much more of a long-term infrastructure story. So as you, I hope, noticed on the Alliance membership slide, what this means is sort of new market leaders, right? New innovation and a reshuffle within the Pro AV manufacturer community. There are those who get it and who are on board quickly and take action, and those who will be slow. We saw something very analogous, not less than a decade ago with HD-based-T, right? If you're familiar with this technology, HD-based-T came out and there were winners and there were losers, right? It really reshaped the industry. And SDVoE, we think, has the same power to transform manufacturers' businesses. So again, as I started at the beginning, I wanted to talk about underlying technology, I wanted to talk about activities of the Alliance, and finally, I wanted to talk about how to participate, right? And the broadest participation comes in through things like the SDVoE Academy, right? I really, I'm quite confident that there's great content there, and I strongly encourage you, if you haven't seen it already, to log on, check it out, register to become part of this community, right? There's more than 1,000 users that are registered within the community. There's, I mean, it says on this slide 500, but I believe at Infocom we were over 600 or 700, right? This number is sure to grow, right? And this is a publicly published thing, right? It's a way for your end users to find you or to know that you know about SDVoE. There's also I know it sounds sexy, but there's an SDVoE blog, which is actually wonderful content, right? SDVoE, this ecosystem brings together such a diverse range of participants, right? Diverse range of visions. The blog represents that, right? So there are regular contributions from across the SDVoE Alliance. Laurent has written some. They come from different manufacturers. They come from end users. They come from system designers, right? We have a really great one that was published recently about SDVoE in healthcare, right? Which is a very big and important market for the technology, and some great pieces, food for thought for you and for you to pass on to your or recommend to your customers. The other big activity for the Alliance, of course, is trade shows, right? So we do the Infocom circuit globally, right? So all of the Infocom events, both North America and in Asia now, because they have a circuit in Asia, and of course ISC, right? So ISC in February will be the next big public milestone for the Alliance, and I look forward to seeing everybody there. It's not so far away, right? At least this last one last time, yeah. When you're running an SDVoE system, how do you manage the bandwidth that's allocated for these endpoints, right? How do you make sure that you have enough for the application requirement?
Especially, I would turn it around. I would wonder how we actually could monitor real time what the status of our network is within that 10 GB range from point to point.
This is an excellent question,
I
right?
know.
Excellent question, because it pulls us into this future world of we've created a platform, right? And now there's chance for software implementations on top of the platform, right? So there's today different answers, right? You would have one answer from IDK about monitoring their devices and making sure that that there are no error reports from any of the transmitters or receivers, that they're not able to get traffic through, right? You can obviously there's a monitoring tool set for the switch itself, right? But there is also, and it was a Sony development, right? So Sony at I believe it was IBC last year showed some software that they had created for SDVoE applications to do exactly this, real-time monitoring of the entire network to test for packet error or lost packets that have been lost, to effectively monitor QoS real-time on the network.
It's especially when sending non-compressed video, or will the devices compress and uncompress on the other side? Will they actually do something to the signal, or will the signal remain like as it is, like raw from the start and come out raw at the end?
So Mike has a really great set of slides that he's going to talk about the compression engine that's part of the NINJAR, right? And how this works. And there's a very nice description. Actually, it was the first time I heard it earlier this week, right? I know what it is, but it was the first time I heard him express it, and it's a very clear answer, and it'll be easier with the images, right? But I'll say now, besides the software idea, right, that I wanted to share, right, that Sony has had, is that there's an important say capability of devices like the NINJAR, where these are running on a 10 gig Ethernet network, but the way they're set up is that they only ever use 9 gig for the AV traffic. There's always 1 gig available for regular data applications, right? So it's quite unlike the reverse, where you see people trying to run streaming systems on an existing Ethernet network, and you get quality impacts like green or green screen or blocky effects because you've got packet errors or congestion on the network, right? This is not the same domain.
I imagine there might be like within 4K 60 at one moment, we could say that over one 10 GB network, we could add up like to 10 streams or to 10 sources at this resolution.
Yep.
And have like a sort of bookmarks or that we can actually use. Like 4K 60 is going to be 10 devices. HD could be like up to 40 devices. Or
Oh, you
something.
mean like a calculator?
Yeah, like a calculator or something.
We should revisit this question once Laurent has taken us through the magic of multicast, because this is a very, very key concept to SDVoE architecture, and I think by the end of the day, you'll have the answer to this very good question.
Thank you.
There's two levels of membership, right? There's founders, there's adopters and contributors, right? Adopters, they benefit from the ability to brand their product or their service or attach the branding to their company, right? That they're a member of the SDVoE Alliance, or if they have a product that it's an approved SDVoE Alliance product, right? There's a fee for this annually, right? Beyond that, it's not much more complicated than this, right? There's a bit of paperwork. I'm the person that facilitates this, right? So if you like, catch my card, and you're welcome to write to me to get a bit more detail, right? IDK is a contributor, right? Contributors take a little bit more direct sort of involvement in alliance activities, right? So adopters, they would have to talk to us before launching some kind of event, open house, product demonstration, that kind of stuff. Whereas contributors are free to schedule this kind of activity on their own and represent, in fact, the alliance as they see fit. They take a much more direct role in alliance activities, hosting webinars and publishing case studies and white papers and so on, right? But yeah, it's easy. It's easy. I mentioned there was a fee, though. Yeah.
Many of the events and installs have SMPTE-based stuff as well. You'll have a vision mixer or something. What are you guys doing to address the SMPTE protocols, like the 2110? Is that interoperable with you guys?
No. 2110 has, 2110 from our perspective starts as an answer to a transport problem, right? And much of what 2110 and aims around 2110 intends to address are things that SDVoE not just does, but in fact exists, right? So one way to look at these two is that SDVoE is about 5 years ahead of where 2110 is, right? But I'm guessing many of you here know a little bit about the broadcast market, right? 2110 fundamentally, although it's a standard, right, that people can pull off and implement, right? It is nowhere near the same kind of standard as SDVoE, right? There is no common chipset engine for 2110 based systems, right? Why does that matter? It matters because this means that at a chip level, every manufacturer is creating their own 2110 implementation. And this is why when you go to a 2110 interoperability demonstration, you'll see a nice big chart on the wall that says manufacturer, product, interoperable, yes or no, check marks everywhere, right? And an SDVoE interop demo is like throw anybody's name on and it's one big check mark for everyone, right? So this is kind of a very, very fundamental. The other big one is within the world of Pro AV, we have signal distribution concerns that are not very interesting in the world of broadcast, right? Broadcast has very fixed definitions for sources and displays that, in the wider world of Pro AV, we just don't have this kind of control, right? End users bring all manner of devices and plug them in, and in a 2110 world, it's going to be 10 years, if ever, before they're flexible enough to address things like HTCP, right? It's just not part of them. Meanwhile, SDVoE Alliance comes after a 4 or 5 year earlier period where the building blocks of Netgear and Semtech, which is the chipset provider, and manufacturers like IDK, we were already working together, doing installations, making things happen with devices that were interoperable, that had, discovery, they had a management application. This is a very mature environment, whereas 2110 is nowhere near this. Yeah.
I actually wrote down on my my notepad, Ciao NDI. So because I think it's going to be replaced pretty soon, and New Tech is actually working in a very closed manner, not really opening up to other people, or not in the way they would like. So we are running into a lot of incompatible issues when
Oh, really?
using or trying NDI, try to improve it actually,
mhm.
and our latency is minimum 3 frames.
Yeah, I mean, this is fundamentally a different
So and
technology.
it's
Yeah.
unusable in live situations.
Yeah.
That's why.
It has a different use case, and there's even a world I could imagine where NDI exists alongside SDVoE, right? It's not going to happen tomorrow, right? But certainly, the SDVoE community, we're well aware that the applications that are being built, they have a need for lower resolution or lower bit rate in particular, lower bit rate streams, right? People want to record, they want to get outside of this real-time environment. This is natural, right? And the easy answer today is, the latency between a transmitter and a receiver in SDVoE land is so low that you have no problem to hand off to an NDI encoder, as an example, or an H.265 encoder, right? But so what I'm trying to say is that it's very possible that sometime in the next 4 or 5 years, you're going to see SDVoE expand a little bit to embrace a low bitrate codec, right, and add this to the technology package, right? But because I think it's necessary and interesting, right? But this will be up to first the board of directors and then the market, right? If this idea is really valuable. And my guess would be if we did anything, it would be 265 and not NDI. It's too much risk in this venture.
When I'm using different devices, SDVoE devices, on the same network, what sort of GUI do I need to use?
This is an excellent question. This is I was telling earlier an amazing story about how quick the alliance has grown, right? So there's still some growing pains, right? The API that I described that sits under the software package from each manufacturer, this has the ability to recognize and control any SDVoE endpoint, right? The full capability of everything is disclosed. It's then up to each manufacturer in their software implementation, right, to expose these capabilities. So to give a super simple example, maybe manufacturer A builds products with no USB capability and manufacturer B does include USB, right? A may not include anything about USB in their software sort of real-time or system setup management because they don't see a reason, right? So if you add these devices, you might see an issue, right? So the recommendation from the Alliance is that anytime you wanted to actually mix vendors in an implementation is that you need to do a little bit of POC testing beforehand, right? That this should not be painful, right? But that you're going to want to talk to your primary system vendor and make sure that they're aware of the other things that you want to put in, and that you choose appropriately, right? And then it's going to come down to features. Right? And this is not that much different than the world of IT. And to be clear, the vision for Alliance is not, we're not trying to enable the market to access the lowest cost transmitter and the lowest cost receiver. And we don't expect people to pick and choose based on this simple criteria, right? End users like systems, right? They need the support of a smaller pool of manufacturer when you build a solution. You need to have a few people to call when you want to make changes or you need assistance, right? And this is the vision of SDVoE, right? The benefit of interoperability is that there's no longer a squeeze on each manufacturer to build every kind and every flavor of device, right? And neither is an end user ever going to feel like they're locked to a particular vendor, right? All of us work in organizations that standardize on, this is a Dell house, this is an HP house, this is a Compaq house, whatever the case may be. You get your devices. My company is all iPhone, right? That's the standard for us. But there's nothing that says that we can't change to Android, right? We won't lose all our applications because they're portable. This is the same vision for SDVoE. So, when you want to mix, test would be the answer.
You talked about software a bit.
Uh-huh.
Any software that will be made should communicate with the hardware.
Yes.
Because the SDVoE comes with the chipset.
Yes.
So there won't be any software, a simple software running on a Windows to say to yeah to name a platform,
Sure.
an OS, and from that software being able to control and manage all the SDVoE hardware.
So
He has to be
management applications can sit on today any OS that you like, right? Windows,
yes.
Linux, Apple, right? These are all supported, and there's kind of 4 layers. I don't have a diagram for it, right? But there's 4 layers. There's the chipset engine, right? And above this, the API, right? So the API communicates with individual devices and tells them how and what to do, right?
Yeah, yeah.
Above the API, you have the manufacturer's software implementation. And this could be very simple. It could be only for configuring things, or it could be quite comprehensive, like the IDK example, where they're having both setup and some real-time management capability. Above this, almost always, you have an end-user interface, right? So this is like a Crestron or an AMX or an Extron. There's some kind of a touch panel, right? That's allowing you to direct the system, right? So this was the setup that you saw in the demonstration, the picture that I showed, right? This could easily be an application on a Windows machine, or there's kind of no limit there, right? So if you wanted to have a small app in a Windows format that your user can click some things, this is absolutely possible. Please.
Is it possible to address the IPA directly without going through the manufacturer's software?
No, you need to create some kind of user interface, right? It's not imaginable that you would have anybody ever memorize API commands and use this as a device controls scene.
No, I'm suggesting writing the software yourself to directly address the API instead of using the manufacturer.
Yes, there are. So within the alliance, there are today 2 member companies that do exactly this. One of them is ViewWall, the other one is IMAG, right? They have software implementations that are able to control any SDVoE member endpoint devices, right? In both of these cases, you need to look closely at what are your application requirements, right? And because there are big differences, actually. Interesting differences.
SDVoE API is only open to members.
Yes.
That's
Yes, you need to be a member company to access the API. Yeah.
To the system integrators or end users, you won't have the API, SDVoE API. It is only open to members.
Here, Dave. So you mentioned that obviously there's a chipset involved. Is there any thoughts to the future for like what Dante's done with software and an FPGA possibilities? So you can, for instance, have SDVoE coming out of a computer instead of having to have an endpoint.
So coming out of a computer, this is something that's already being addressed. There are a few companies that have, say, capture cards for in and for out, either available or in development, right? So this is.
But that's still requiring the chipset.
Correct.
Okay.
So there's no soft codec available from SDVoE. It always at some point requires a hardware component.
And then follow-on question on that chipset: is it limited to the 10G network, or if we wanted to, in the future, you're going to have 8K video and stuff, you're going to need much bigger bandwidth on your network, 25G, 100G networks.
Yeah.
Is it scalable already, or is that a whole new chipset?
That's a whole new chipset. The reality is that's a whole new chipset, right? 8K is very much on the minds of many of us within the alliance, but we have things to do today, and yeah, it'll be another hardware iteration for sure. So again, thank you everybody. Thank you to AED. Super setup, and see you at lunch.